Hello everyone. Today we are going to discuss on the concept called blockchain backed order reconciliation system for multi-enterprise integration. This presentation shows on the blockchain concept, and along with that here we are going to use microservices architecture to implement the technical details, and we are going to deploy this in cloud environment. Let's see, dive into the presentation. Here we will explore how this technology advancement transforms traditional supply chain operations by eliminating manual reconciliation efforts, enhancing transparency, and establishing trust between trading partners while setting the foundation for future enhancements. What are the basic challenges in the supply chain environment? So, one is unprecedented complexity. Supply chain operations in multinational enterprises have reached unprecedented levels of complexity. Global supply chain complexity directly influences international businesses' performance, with multinational enterprises processing an average of 2.3 million orders transactions annually across their global networks. The other challenging thing is like critical operational challenges. Studies reveal that 82% of companies experienced supply chain disruptions in 2023. Due to data synchronization issues, order discrepancies require an average reconciliation time of 48 to 72 hours, with 23% of cases demanding extensive manual intervention for resolution. And the third challenge that facing is substantial financial impact. Enterprises invest between 420K and $670K annually in reconciliation efforts. The multinational enterprises with higher levels of supply chain complexity experience a 15 to 20% of increase in coordination costs, at those with effective technological solutions see a 24% improve in market performance. So these are the challenges that we usually face during the supply chain environment. And coming to the system architecture, so here we are going to develop a system with the base foundation with the Hyperledger Fabric blockchain network. On top of it, we are going to build the framework with Hyperledger Fabric framework and blockchain network, microservices, and smart contracts API, GraphQL. All this business logic implementation comes into the picture. After that, on top of it, we are integrating APIs, in architecture, standardized data models, all these things. Our multi-layered approach leverages distributed ledger technology alongside modern microservices platforms patterns. Performance analysis demonstrates throughput capabilities of up to 2,800 transactions per second with an average latency of 0.5 second across organizational networks. The Hyperledger Fabric network provides the foundational layer for immutable transaction recording, while microservices manage business logic and API exposure. Apart from that, smart contracts automate order validation and reconciliation process, while the GraphQL API provides flexible data querying capabilities. How the core components performance will be. If you see the core components performance, our system achieves remarkable performance across all components, where coming to the Hyperledger Fabric framework, it maintains a consistent blockchain generation time of 0.5 seconds and achieves a validation rate of 2,200 transactions per second. With 99.98 successful transaction rate, the microservices layer effectively processes 1,500 concurrent logistics events with average response time of 80 milliseconds. And coming to the middleware technology like Apache Kafka, reliably handles 75,000 events per second with latencies below 15 milliseconds. And coming to the smart contracts, it completes standard transaction in 180 milliseconds with 99.95 successful execution rate. Whereas the GraphQL API consistently handles 1200 queries per second with response times of averaging 95 milliseconds. If you see the technical implementation of this idea, the blockchain implementation, smart contract logic and microservices and data flow and processing, The Hyperledger Fabric network deployment consists of multiple organizations representing key supply chain participants. System utilizes a channel-based architecture, processing up to 1500 transactions per second while maintaining data privacy between participants. Smart contract logic. The smart contracts developed a chain code in Golang from the core business logic layer. Enterprise implementation shows that well-designed smart contracts can automate up to 85% of routine business processes, reducing manual intervention by 70%. Microservices architecture is built on Spring Boot. The microservices architecture demonstrates significant advantages in scalability and maintainability. Properly containerized services handle up to 1000 transactions per second with response times of under 100 milliseconds. And coming to the database and data processing related, where we are using Apache Kafka to maintain all our transaction between the modules, and the system implements a comprehensive data processing pipeline, event-driven architecture achieving event processing latencies under 50 milliseconds for 95% transactions. This is, if you see the achievement, it is very good compared to the old latency approach, right? And we have a better system design architecture and good technical implementation details. If we have a robust environment where we can deploy and the performance achieves more, that will be great. So here we are using AWS Cloud Deployment or our deployment platform. In this, we are using Amazon EKS, which provides foundational for container orchestration, implementing true cloud native architecture. Cloud native container deployments reduce deployment times by 65% and improve resource utilization by 45 to 50% compared to traditional methods. And coming to the database platform that we use here in Amazon, we are using Amazon RDS service for implementation of cloud native best practices for data persistence. This is available in multi-available zones so that we can reduce the burden on the application, and it achieves 99.99% success rate even during peak operations, with automated failover completing within 60 seconds. To reduce more burden on the data, we also use elastic caching implementation, which utilizes a distributed caching architecture that automatically scales based on demand. Cloud native caching strategies improve the response times by 70% while reducing database load by more than 60%, right? We have very good deployment and where we can maintain the software or the implementation details. We also need to follow the security standards. Coming to the security standards that we are taking care, that is, one is network security. Here we are using TLS 1.3, which is a perfect forward secrecy. The system effectively mitigates 99.9% man-in-the-middle attempts and can withstand sustained attack volumes up to 300K malicious transactions per second. That's a great security in terms of security mechanisms in the network layer. And coming to authentication and authorization, authentication mechanisms leverage blockchain native identity management combined with traditional PKI infrastructure. By following this, we are reducing unauthorized access attempts by 99.8%. The system processes access requests through a consensus-based validation mechanism while ensuring complete auditability. And also we are implementing multi-signature operations security. Here, this helps to manage critical operations implementation in blockchain native multi-signature protocols that require consensus from designated validator nodes. It prevents 99.99% of unauthorized transactions attempts while maintaining transaction finality times under 2 seconds. And coming to the audit and monitoring security, the audit system creates tamper-proof security logs supporting throughput of 50,000 events per second. Distributed system monitoring incorporates both network level and application level security metrics, processing 2 terabytes of daily security events. That is very great in terms of security for auditing. What will be the operational benefits and the results? So we are achieving very great operational results. Verification time reduction up to 89% and traceability accuracy to 99.6% and manual process elimination up to 85%, visibility improvement up to 92%. Implementation analysis demonstrates significant operational improvements across multiple dimensions. System has eliminated approximately 85% of manual documentation process with automated smart contracts handling verification and compliance checks. It has strengthened this relationship between supply chain participants and significantly improved consumer trust. The blockchain solutions reduce dispute resolution times from an average of 45 days to just 5 days, while decreasing error rates in order processing from 5% to 0.1%. That's a great achievement, I can say. What will be the financial impact? If you see the financial impact in three major areas, which is transaction cost reduction, blockchain implementation reduces a transaction cost up to 65%, with the small scale farmers seeing an average increase in profit margins of 25% through improved market access, reduced intermediary costs. And coming to working capital improvement, the processing efficiency has improved significantly, and the study shows that the next generation supply chain system reduce working capital requirements by 30%, improved inventory management, and faster payment processing. That's a very good achievement in terms of working capital. And coming to administrative savings, here the report shows that average annual savings of 3.2 million through reduced administrative overhead and improved operational efficiency. Immutable audit trails have proven particularly valuable for regulatory compliance and reducing compliance verification by 75%. So these are the best implementation details, and financially it is perfect. We are having a very good cloud deployment environment to make this particular idea to very good maintainable state by reducing lot of things, right? We can also do feature enhancements for this idea by implementing AI ML integration, IoT integration, cross-chain interoperability, and enhanced analytics and mobile development. By implementing these advanced features like AML, IoT integration, it automates more process and reducing more burden on the system, inventory cost, inventory management, in financial things, so many things we can reduce. It also reduces 95% of manual efforts in a small scale. Coming to larger supply chain industries, it eliminates up to 90% of manual reduction. With that, I'm concluding this, the transforming supply chain management with the trust and transparency, operational efficiency, innovation pathway, and scalable foundation. The blockchain-backed order reconciliation system demonstrates transformative potential in resolving long-standing challenges with multi-enterprise supply chain environments. The integration, distributed ledger technology, and modern cloud-native architecture, along with microservices environment, a robust foundation for secure, efficient, and automated order management. The demonstrated improvements in operational efficiency combined with potential for future enhancements through AML, IoT integration position this solution as cornerstone for next generation supply chain management. This successful implementation showcases how blockchain technology can revolve business process while providing a clear pathway for continued innovation. With that, I will end my presentation here. So hope you liked it and you want to know more details on top of it. If you are If you want to know more details, you can always shoot an email at Kumar, Nilisetty @gmail.com. Thank you. Thank you for your time.